Thank you, Tom, for a really warm introduction. So I'm really honored and gratified to be here. I'm going to start by acknowledging a professional problem that I have as an epidemiologist, and that is that we have a habit of saying further research is always needed, or further research is needed is usually what we say at the end of every paper, and we explain 56 other leaps and bounds we can make in our understanding of what chemicals do to our hormones and human health. But the fact is we know so much. And we know that these problems are urgent and that we need to act. So that is the tension that is frankly manipulated in a way to dodge action. So as you think about the evidence here today, there are going to be points that I tell you that we need to do more. And sometimes we say that a bit too much, maybe to help get us grant funding. But the fact is that we have so much to do, and the stakes are really high. Tom set me up because with that Bradford Hill quote, because he talked a lot in his landmark lecture about the stakes really mattering. And when we have described causality and the definition of causality, we seem to cast it the opposite way to the way Sir Austin Bradford Hill actually wanted it cast. He described it. We cast it often as dyadic. Either a drug works or it doesn't work. But the fact is, it's not so simple. I can tell you there are things about childhood lead exposure that we still don't understand. But people accept that lead damages kids' brains. Well, the fact is that we have a lot of evidence for action now, and the stakes are really high. And that's really what we need to focus our energies on. So I'm going to provide that evidence today as best I can. I'm going to acknowledge the warts here and all. To borrow from a famous philosopher named Ted Lasso, we need to stay curious and stay curious about the invisible and make these problems visible. So I'll jump right in without further ado. First, some disclosures. I have written a book for a lay audience that has provided me some financial support, and insofar as that and some collaborations I've had with companies trying to do the right thing in the EDC space, that can present a conflict of interest. So having explained that, I'll jump right in. I've added some ancillary slides that provide that are probably overlapping with other presenters. That's the joy of being among such wonderful friends. So I'm going to skim over a few of them. And I hope you'll focus more on me than on the slides. I think we get a little bit digitally toxified in a different way. So I'm glad to see that I can point backwards and the slide actually moves, so I can move around a lot more ably. So we know that there are natural things in the environment that hack our hormones. But what we're talking about here is the rapid increase in synthetic chemicals in our daily lives that have accelerated that phenomenon in a way that affects us from cradle to grave. And that's really the theme of what we'll talk about today. And I want to harp a little bit about the mainstream nature of this science and really emphasize the history. So this is where I'm going to connect the morning session with what we're talking about today. So the Endocrine Society scientific statement to me is a big landmark in 2009. You had the WHO UNEP report in 2012. I'm privileged to be a member of the next iteration of this document that is a work in progress at the present time. So this is a constantly evolving field. These two reports were essentially endorsed in 2015 at the Strategic Alliance for International Chemicals Management meeting that I attended. That's the UN body for chemical safety in 2015. And there's this famous footnote that said that only the pesticide and chemical industries had disputes with the science. That's a really important footnote, because that just speaks to the consensus that was there at that time. And not long thereafter, the Endocrine Society published its second scientific statement with 1,331 scientific references, particularly documenting the human evidence for action. Now, I will tell you, as a member of multiple societies, writing a scientific statement takes work. So for the Endocrine Society to put up a second scientific statement 6 years after the first, there had to be a lot going on already in that short time interval. And normally we wait a decade because scientists are busy. These statements don't necessarily generate grant funding, for example. So it's important to emphasize how much we had to get our sweat up, if you will, about this phenomenon. So again, just to continue on the mainstream recognition, International Federation of Gynecologists and Obstetricians, American Academy of Pediatrics, focusing on chemicals intentionally added to food. Jerry and Ankel did a wonderful talk, really synthesizing all the evidence about metabolic disruption. The World Obesity Federation has suggested specifically policies to reduce EDC exposure to reduce the effects of obesity and diabetes and combat the obesity and diabetes twin pandemics that we face today. So this is not just individual scientists cracking comments about various things. Is there an issue up there? Oh, I'm good? Okay, I saw your hand up. I just wanted to make sure we're all fine. Thank you. So this is not just individual scientists or activist scientists, as some will call us. This is mainstream. So let that sink in for a minute. We need to be here and now. So what do we know? The effects that were first described were really the effects in humans on the developing brains of young kids. So we know that the baby relies on thyroid hormone until about the second trimester of pregnancy, and then starts to have the thyroid hormone come online. And if you, in the clinically normal range, this isn't something an obstetrician can detect. You have shifts in thyroid hormone function, you can produce cognitive deficits, autism, and attention deficit hyperactivity disorder. So this is real, and it's not something that we can control with testing or pharmaceutical interventions. And we also know that sex hormones are crucial. So you already heard about Shauna Swan's work about the import of androgen and estrogen on brain development as well. But those are important influences that can also be disrupted. So there are multiple pathways involved. Organophosphate pesticides were the first suite of chemicals to really come on the scene as hacking our thyroid hormone and thereby affecting brain development. And here's again where you have consistency from multiple independent birth cohorts, controlled for independent and other factors that may so-called what we say confound the association. They could not rip the association away to non-significance. And then it's not just effects on neuropsychological testing, IQ in children that were disrupted. You see those images. Virginia Rao and colleagues at Columbia University did magnetic resonance imaging on the kids who were both highly exposed to pesticides in utero and the kids who were less highly exposed. And you saw frontal and parietal cortical thinning that matched the neuropsychological effects. So when Sir Austin Bradford Hill talked about causality, you talked about not just consistency across independent findings, you have consistency across threads of evidence and different measurements of the same phenomenon. Well, this is where it's at. Brominated flame retardants, same story. Now here's where policies are very different. And I don't want to offend the Californians in the audience, but suffice it to say that there was a law intended to prevent the spread of fires that killed people. And this was the cigarette era. Folks were smoking in their beds, falling asleep, causing fires, and killing themselves and others as a result. So flame retardants were going to be this panacea that were going to slow the spread of fires and thereby save lives. Well, I hate to tell you that didn't work. But it left a log-fold higher amount of flame retardants in North Americans compared with the rest of the globe, such that if you measure, to this day, European levels, Swiss levels as well, of brominated flame retardants. They are basically 3 to 10-fold higher than lower than the American levels. And Canada and Mexico, you can blame NAFTA for that. Because we added flame retardants to polyurethane foams in furniture for 40 years. Now, California rolled those laws back, but this is where the epidemiology tells a story, almost providing a natural experiment. So all the America studies show consistent exposure response functions with cognitive deficits. The European studies are a bit meh, to borrow an American adage, a way of saying it. So there are associations that are telling, they're subtle, but they're not as robust as the American associations. So that's because, frankly, if you can't detect it, you may have a hard time distinguishing exposed and unexposed groups. So that's why this Spanish study is, well, modest in the degree of associations. So I'm going to shift from brain now to metabolism. I'm going to skip over this slide and just emphasize the breadth of chemicals that are known to disrupt metabolism and contribute to obesity and diabetes. But others have already done justice to this topic. The thing I will add before going there for a moment is that the late David Barker, a British epidemiologist, also described another important phenomenon, the developmental origins of health and disease. And he described it in the context of gross in utero nutritional deprivation contributing to obesity and heart disease and death in British men 40 years, 50 years later. Well, we know that it's not just nutritional insults that can drive these effects, environmental insults, and subtler influences, not gross nutritional deprivation, can induce the kind of phenomenon that we're talking about here. So it's within that context that I'm going to walk you through some of the findings. Now, others have also already described what bisphenols are, so I don't have to really do too much other than to say that BPA is the prototype obesogen and it makes fat cells bigger. It takes muscle and bone and transforms mesenchymal stem cell fat into fat. It is a synthetic estrogen, so it can have sex-specific effects on body mass, and is an antagonist to adiponectin. So it can have, as we'll talk about, cardiovascular effects beyond it. And we've all hinted at this, but the fact is that there are now, apologies, this says 40, but it's more like 140 replacements of BPA. And what little we know about one replacement is it has the same effects on wildlife, embryo toxicity, among other phenomena. So we are whacking the mole. We need to, and that'll be a theme of this presentation, regulate chemicals or treat them by class, because they're just not that different when we think about the toxicology. Phthalates tend to coexist. I'm going to just add a little bit of nuance to others' presentations and just distinguish between the lower molecular weight phthalates that tend to be more anti-androgenic and the higher molecular weight phthalates which tend to be more active in the peroxisomal proliferator activated receptors, changing how genes are expressed. So again, another theme here is what we're not talking about is always a receptor phenomenon. This is not that visible. It's much more invisible and insidious when we're talking about epigenetic regulation. Epigenetics has really exploded the scope and depth and the levels of exposure at which EDCs can affect metabolism. So I'm just going to take you through some of our own epidemiologic findings and those of others that have really brought this home. I've had the privilege of working with colleagues at Erasmus University in a large birth cohort called Generation R that was able to measure urinary levels of bisphenols and phthalates in 3 trimesters of pregnancy. And here we found that phthalic acid, an end metabolite for all phthalates, was associated with lower fetal weight. Keep that in mind when we think of the Barker hypothesis and go through some of the other slides to follow. All the way through 40 weeks of gestation. We also saw associations of phthalate exposures with premature births. Now, mind you, the Dutch population in that region has a like 3% premature birth rate. It's really low. So finding this degree of association is a really strong signal in a population that has a low risk profile to begin with. When we looked later at postnatal growth, and I'm going to just leave you with this thought and say, well, Leo, you just said that intrauterine growth restriction should induce a profile of obesity. These data don't seem to make too much sense, but at least for phthalates, where you see lower BMI or null associations, and then bisphenol showing lower BMI. But then remember, I have to emphasize here, when we measure body mass index, that is a crude measure of fat being in the wrong place, or the broader composition of the human body. And when you look more deeply at the data, you can see that bisphenol exposures are associated with lower bone mass, which is not a good thing. We know that osteoporosis is actually increasing and accelerating, and what you are as a young adult, bone-wise, mass-wise, sets you up for having earlier osteoporosis, bone fractures, and things like that in later life, not to mention childhood bone fractures, which are on the rise. Now, moving along there, I want to just emphasize for a moment large national data that confirm this phthalate preterm birth relationship, which is very strong. It might be oxidative stress as much as pure endocrine disruption, but oxidative stress is an endocrine disruptor. Let's be cognizant of that. And again, this issue of chemical replacements rears its ugly head. We looked at a large US birth cohort called the Environmental Influences of Childhood Outcomes Program. It's a large national program. It's the large national children's study that has taken forever for America to implement, but suffice it to say it's there. And we looked at pregnancy exposure to phthalates and prematurity. And what we found were levels of DEHP associated with prematurity. Okay, that's not a really novel finding. But then we looked at the DEHP replacements, and they had actually stronger associations with prematurity and shortened gestation. And when you extrapolate those effects to the US population, that's 5 to 10% of prematurity. $4 billion in direct medical care, as well as lost economic productivity, because premature babies have less time to develop their brains in utero and have lower IQs. Not the most comforting set of phenomenon, as we'll talk about. But there's hope at the end of this presentation, I promise, if I don't get the hook for running over. We are in Switzerland. So suffice it to say that there are multiple and unfortunate longer-term metabolic effects. And again, this is where I bring up the Barker hypothesis. I told you that bisphenols were associated with lower body mass index, which doesn't make any sense. And then I showed you that phthalates were associated with null effects on body mass at age 10 or so. Well, when you look deeper, it's not just the body mass index. That's a crude measure, as I talked about with bone. We looked at phthalate exposure in first trimester and found increases in pericardial fat. Pericardial fat is the worst fat depot known to humankind. It is the most predictive of cardiovascular disease and mortality. So this is not a comfortable thing to present, but it's very compelling evidence that these are not good chemicals to have in the human body. Now, some will look at the bottom of this slide and say, wow, you show some positive associations of your chemicals with blood pressure and triglycerides. Chemicals are a good thing, right? I argue that we are dealing with a complex mechanistic problem here that we need to disaggregate the why behind it. Maybe we can find some therapies to support or interventions to counteract based on these data, but this is a wild mess that we've unleashed in human metabolism. And that is really, so it's not a good thing. It's a thing we don't have control over. And that's really important to emphasize as we talk about this. So these are important findings, even if they're paradoxical. Now, I'm a pediatrician. I'm going to tell you, of course, that kids are the most susceptible, susceptible windows of development, greater years of life, higher doses of exposure to these chemicals compared to others. But life is a window of susceptibility to endocrine disrupting chemicals. So let's talk about that. We know that phthalates are antiandrogens. We know that low T is a marker of or predictor of adult cardiovascular mortality. We looked at large national longitudinal data measuring urinary phthalates 10 years before, and then looked at odds of death linking to the National Death Index. And we saw an increase specific to food packaging phthalates, the DEHP class. We couldn't look at the newer phthalates because this is an older cohort. That's the thing about epidemiology, is there's disease lags. It takes a long time to find these effects, and then we have to go picking up the proverbial pieces. When you extrapolate these effects across the US population, 50,000 deaths, $24 billion in lost economic productivity. And that's just in 55 to 64-year-olds. Stay tuned, because there are some larger databases we're leveraging to look at the potential bigger picture globally. But bisphenols, I told you they antagonize adiponectin. They are associated with narrowing of the carotid arteries. They're associated with reduced heart rate variability, which is another bad marker of cardiovascular risk. And they're associated with severity of coronary artery disease, not to mention, I don't know what happened with that slide, but I apologize. That is also an association with cardiovascular mortality that we identified. The phthalates have a different independent effect. They appear to be a little bit more robust than bisphenols, but if you have this totality of evidence, not to mention on the right, you see an increase in incident diabetes in a French large case cohort study associating with bisphenol A and bisphenol S. So we have a pattern here that is just not good from a broader cardiovascular risk perspective. So as much as we are infertile, we're also sick. PFAS, nonstick chemicals, have their own sets of problems with it. They're widely detectable. We know they shrink babies' growth, which is not good. They've been associated with increases in obesity to boot. This problem might be going away because there is a later meta-analysis that shows a null statistical finding, but let me pause there for a minute, because PFAS levels, at least the longer chain PFAS levels, are doing this over time. Because we did the right thing and got a phase out of the longer chain PFAS. But as you reduce exposure and you add cohorts that have lower exposure levels, that the noise becomes louder. And the statistical association might well go to null. I'm not going to tell you that's a confirmatory explanation, but it's something to keep in mind as you look at least one other systematic review. I told you I was going to talk about all the evidence, not just some of the evidence. But suffice it to say, again, with PFAS, life is a window susceptibility. It's not just early life. We know that PFAS are associated with incident diabetes. They're associated with gain back of weight in people who've fasted and done things to improve their lifestyle. So none of these findings are free of the notion that diet and physical activity are two legs of the proverbial stool when it comes to obesity and diabetes. I don't have to do much on fertility, fortunately, because I know the giants that I'm presenting after very well, and they've done a bang-up job of explaining this. We know that in utero exposure to phthalates shortens anogenital distance, which is a marker of male to female sex hormone function in utero. And we know that what you have when you're born is, with the one exception of a little pulse of sex hormones in mini puberty, in infancy, around 2 months of age, that is what you have as an anogenital distance all the way to adulthood. And your adult AGD is predictive not just of sperm count, it's also predictive of cardiovascular disease and risk. So there are multiple endpoints that are sex hormone sensitive. As Pete said, I often use the analogy of, it's actually Henry Russell, a UCLA football coach, says that winning isn't everything, it's the only thing. And it's attributed to Vince Lombardi, this famous football coach, but it's not really his phrase. So I don't know whose phrase it really is, but I'm just going to go with it. The Endocrine Society isn't just a thing, it's the only thing. And there are multiple disease endpoints because the endocrine system is a master regulator for so many basic biological functions: temperature, metabolism, salt, sugar, and even sex. So now I've depressed you, and I'm going to depress you a little bit more, but then give you hope. And I need to remind myself how much time I have. If anybody's got that out for, okay, I'm going to have to hustle, but let's do it. We know based upon methods developed by the Institute of Medicine back in 1981 that endocrine disrupting chemicals cost society substantially. We reduced these cost estimates before publishing them by the uncertainty with their causation using criteria published by the Intergovernmental Panel on Climate Change. And across, this is just 15 associations, a subset of chemicals due to the few, a subset of chemicals to begin with, and a subset of diseases due to the few chemicals we studied, and a subset of costs due to the few diseases due to the few chemicals we studied. I'm almost getting exhausted talking about the conservativeness of these measures, and this might sound really liberal. So suffice it to say that endocrine disrupting chemical exposures in Europe cost 1.2% of the gross domestic product, 163 billion euro a year. And that is largely driven by pesticide exposure and effects on neurocognitive development. If we update these numbers with other cardiovascular and other endpoints, the numbers are likely even higher. In the US, the problem is even worse. Remember the brominated flame retardant problem that I talked about? We have costs of $340 billion in the great US of A, 2.3% of gross domestic product. Policies predict exposure. Exposure contributes to disease, and disease costs our economy. The good news, if you're an American, is we have a Food Quality Protection Act unanimously passed in 1993 by both houses of Congress that required a 10-fold safety factor be added for pesticides. And that actually is a reason why the US pesticide costs are actually paradoxically lower than you might expect compared to the European costs, 42 billion compared to 121 billion euro. So again, policies are really important. I'm sorry about this, but I'll be able to just fix it with my words that you'll hear. But PFAS also add an additional $5 to $62 billion annual toll due to 13 disease endpoints that we know are associated with PFAS exposure. If there's one thing that hasn't been said, I'm going to emphasize it now. Plastic is a huge driver of EDC exposures. And mind you, plastics come from petrochemicals, so there's the connect the dots. When you just take the plastic attributable subfraction of these costs, the cardiovascular mortality I've talked about, the PFAS effects, and the endocrine disrupting chemical effects I described before, and you roll that up, and then you take away the costs that are non-plastic, in the US, that's $249 billion a year. The other point I want to emphasize is plastics are more present than we realize. Nail polish. I mean, you don't think of nail polish as plastic. You don't think of nonstick cooking as plastic, but that's plastic. It's literally a word out of The Graduate 50 years later. Plastics was the future, and hopefully it needs to be the past. There are disparities driven by race and ethnicity through increased exposure due to direct marketing or to food deserts and other phenomenon that drive disparate exposures in minoritized and low-income groups. And they bear the disproportionate burden of these EDC exposures. Okay, enough of the depressing part, and I think I've got a minute to go. There are safe and simple steps we can all take to reduce exposure, and then I think I'm going to have to skip the policy part, but others will cover it. So suffice it to say that we know you can reduce pesticide exposures in days, and this has been proven in high-income populations as well as low-income populations. So please no one tell me that this is a bougie thing, because it's not. And it's a 1 to 3 day for most of these chemical exposures. Many of them are non-persistent. So this is something you can do right away. And if you sustain that intervention, maybe in weeks you have changes in hormone levels that are favorable, and in months you have disease risk, chronic disease risk that's reduced substantially. We know that for bisphenols and phthalates, you can do the same thing in high-income populations, BPA and DEHP metabolites here, and then in low-income populations, just by reading the label of cosmetics and personal care products. That is how literally so frickin' simple this can be. We know that the household environment or the work environment is important too. A group of Harvard somehow figured out how to make a natural experiment where different grades of healthy building interventions were done, and dust levels in a graded fashion were reduced substantially, not just for PBDEs and PFAS, the so-called older chemicals, but the replacement twisted siblings of the PBDEs, I like to call them, called organophosphorus esters. Which are an emerging thyroid contaminant and contributor to obesity. If there's something that I can beg you to do today is to use less plastic. In particular, glass and stainless steel are perfectly good. Cast iron and stainless steel. Last I checked, olive oil is good for you, as an aside, as opposed to I appreciate it's a little extra elbow grease in scraping things off. I will stop there. I could go on about policy interventions, but you have multiple panels already covering that, so I'm going to speed past my final slides here and just close with, let's see if I can do this. I will just say as a pediatrician, that the healthcare industry is part of the problem, but it's been part of the solution. We got mercury out of medical waste incinerators first, well before coal-fired power plants. So the healthcare industry, in my opinion, can actually be leaders in promoting health through its own environmental actions. Unfortunately, there are organizations like Healthcare Without Harm that are leading in that front. So suffice it to say, if you had seen the later slides that I just skipped over, we do also need particularly global biomonitoring programs in low and middle income countries, because that's where the exposures are moving in the context of protections that are just not the same as the high income countries. We need a hazard-based model for we cannot work on risk. We can't extrapolate from low dose exposures in animals to the lowest dose exposures that are available in humans. Our bodies are just too smart compared to the human mind to really extract that kind of ability to disaggregate effects. And I would argue we're at a point similar to a carcinogen 60 years ago and need an international agency for research on EDCs to really have an independent body that vets chemicals for their safety, and preferably classes for their safety. Thanks for your time.